All right. So we're about 5 minutes past, so I'm going to go ahead and get started. Thanks for joining today. This has never happened before, but I don't know if you're there, if you can hear me, but Nikita, you are the only guest in this workshop today. If you can hear me, you should be able to use the Q&A. So if you're there, if you can hear me, let me know. And then I'm happy to bring you off mute and put you on camera, and we can just kind of talk through the content of the workshop face to face, or we can keep this kind of as is. It's up to you. Awesome. Okay, great. You can hear me. So I'm going to see if I can figure out how to unmute you, and then I will, here we go. Okay, so I've just allowed you to talk. So let me know now if you can hear me.
Mm.
Oh, there we go. I heard something.
Yeah, that's good.
Oh, nice. Okay, excellent. Hello, how are you?
Yeah, I'm good. How are you?
I'm doing well, thanks. I'm sorry, I know this is probably not what you bargained for, but it's weirdly, we normally have about, I'd say 15 to 20 people join this. I've never seen with just one.
Oh, yeah,
So
I
in a
know
way, I
it.
suppose that makes you a little bit lucky. So what we'll do is I'll go through all the content just as I normally would. But if you'd like, feel free to ask questions. Just stop and cut me off. I'm happy to talk about anything specific that you'd like to discuss or anything that you'd hope to get out of it.
Yeah, sure then.
Okay. I guess just before I get going, so how familiar are you with Databricks? How familiar are you with Delta Lake?
Yes, I'm not familiar with the Delta Lake, but right now, I work as a data engineer here. I usually we use ADF and Databricks at the same time. We written some custom notebooks to run some Python scripts, and we connect this Databricks environment to our Power BI for reporting purpose. Uh,
Yep.
yeah,
Okay, nice. So ADF, I assume largely that's for the majority of the orchestration. And then Databricks actually executes a lot of the ETL, and then you visualize all the data with Power BI.
yes, correct. But we do have some workflows on the Databricks environment. We
Mhm.
use it just for running certain notebooks on certain schedule times.
Okay. Yep. Makes
Yeah.
sense. And then does the organization that you work for, do they use Delta at all? Or no, actually, there's no Delta in use today.
Uh, they don't use Delta much, but I do see like we do have some tables that's been
Okay.
logged. Yeah.
Okay. Nice. All right. Well, great. So the first part of this, say the first like 10 to 15-ish minutes is just some slides where I'll introduce Delta. We'll talk about kind of why does Delta exist? Where did Delta come from as a concept? And then we'll talk about kind of the kind of implementation of it in Databricks, how it works, and then we'll get into some of the hands-on stuff. Does that sound okay?
Sure. Yeah. Sure.
Cool.
That would be great. Yeah. Thank you.
And then I guess last question from me before I get started. What brought you to the workshop today? You've heard about Delta previously, I imagine, and maybe just want to learn more about it?
Yes. So recently we had an issue in our Databricks environment. Um, I didn't get Adriana from your Databricks team suggested to have some workshop sessions with your team to know more about this Databricks platform, and we have like a feature scope of Databricks using the Databricks for our AI and machine learning purpose. So she suggested us to have this workshop, and I would like to know more on this computation part. How do we manage those compute clusters? Yeah, we are trying to find a better way to store our data, and for that purpose, I didn't have like much hands-on on this Databricks environment. I used to work on the Snowflake environment previously in my other
Okay,
companies, so I recently started here. Yeah, that's the reason.
gotcha. Okay, great. So in that case, like I said, we'll go through all the main content for the webinar. But there will be a section where we look at the clusters. And if at that time you want to talk a bit more about cluster management, if you want to talk about all-purpose clusters versus job clusters and the different varieties therein, I'm happy to spend some more time on that subject than otherwise we might during this workshop.
Okay, sure. Thanks. Okay.
Yeah, for sure. As well, it's possible, you're the only one here still. It's possible some other folks join. If that's the case, then I'll probably do the same. I'll bring them off mute just so that we can have a discussion. But 10 minutes in, there's nobody else here. I don't think we're going to get many more. So, all right. Without further ado, I'll dive in. So here's our intro to Delta workshop. We'll do our little overview of Databricks, overview of Lakehouse and of Delta Lake. It probably won't take as much time as it suggests on the slide there. Meet the presenter. That's just me. I'm Declan. Just for your context, I'm a senior solution engineer. So basically, I am the primary technical half for like an account executive or whoever your primary contact is at Databricks. I work with people like that as kind of the just the technical side, if you will. So I answer technical questions. I provide technical guidance. That's kind of typically what my role is. I'm based on the East Coast. I'm up in Vermont in the US, and I've been at Databricks for just under 4 years now.
That sounds great. Yeah, I believe like the one I have contacted previously is also from your team.
Oh, nice. Do you know who is the account executive that
Yes, it's Adriana De Luca.
let me see. Adriana
De Luca.
De Luca. Oh, nice. Here she is. Adriana. Aha, okay. Yes, so Adriana is on a team. I used to work very closely with that team. I don't think she and I ever crossed paths, but yes, I'm familiar with that team quite well. So that's great. Yeah, you've probably worked with some of the other SAs that I work quite closely with in that case. So that's terrific. Cool. Okay, so Databricks, like you said, you use Databricks, so I won't spend too much time here, but who are we? We're data and AI company. We've created a handful of different now open source technologies. So Delta Lake, MLflow, Spark, Mosaic, and DBRX. You mentioned that you were interested in doing some machine learning in the future. You have some ML projects coming up. Something like
Yes,
MLflow will help a lot for ML ops. If you're not already familiar with MLflow, I'm happy to chat more about that as well. Otherwise, we've been around for about 10 to 12 years. We have over 4 billion in investment, a whole lot of revenue now, and we've been recognized pretty consistently across a variety of domains from database management to data science and machine learning. And also, are you familiar with Apache Spark? Just this one here.
yes,
Okay. Have you used it for data engineering previously?
yes. We use it for the better and faster code executions, and yeah, for optimizations purpose. Yeah, we do run some Spark code.
Okay, terrific. Yeah, it's the founders of Spark are the ones that actually created Databricks, if you're not already aware.
That's great.
Okay, and then we'll get into some of the main content here. But basically, like Databricks was founded, really the idea was for it to be managed Spark. So it was notebooks and it was the ability to use Spark in those notebooks. And then over the last 10, 15 years, we've evolved into this much grander platform with more features, including Delta, which of course we'll talk about here. So just a couple slides to set some more context. So 83% of CEOs say that AI is a priority. There's a lot of business value to be had to be created by AI. You can see this is just a number from 2022. That's probably a pre ChatGPT number. So I'm sure if you asked today, that number would probably be much, much larger. But actually kind of moving data projects ahead is a challenge. So 85% of big data projects fail. 87% of data science projects never actually make it into production. So a lot of companies have success with their data and AI projects, but most companies still struggle. And that's why Databricks built Delta, because we have customers with anywhere ranging from petabytes of data on the heavy side to gigabytes and megabytes on the small side, that they ultimately struggle to process or work with in an efficient way, and in a way that enables them to have kind of one copy of the data with which they can execute all of the kinds of use cases they might want to, like reporting in Power BI or machine learning and AI use cases as well. So the world kind of that everything comes from, we have our data warehouse world, we have our data lake world, that typically, traditionally have been split. Data warehouses in the past have been great for business intelligence. They are highly structured, so they're very performant for kind of BI type workloads. And ultimately, one can spend less time actually cleaning and aligning schemas and more time just building reports. So data warehouses are great for that purpose. But because they only support structured data, sometimes increasingly semi-structured data, and only are really great for SQL, there's limited support for machine learning. So you mentioned you worked with Snowflake previously. It's a great data warehouse. And over the years, they've done a lot to support Python increasingly and to support ML. But in general, it's still not quite what I would consider to be a true ML platform, because most of what they've done is rooted in data warehousing. So it's a great platform. And I think they've come a long way. And it's nice to see where they're going with it. I think it's really validating to see that kind of unified approach. But yeah, so Snowflake really great for that purpose, as well as a couple other warehouses you see listed there. But largely great primarily for working with SQL, not so great for Python, not so great for ML and those kinds of workloads. On the flip side, data lakes are kind of the foil, the nice kind of opposite there. So typically great for ML, great for working with a variety of different types of data, be it structured, semi-structured, unstructured, but that can often turn into having a really messy data lake. So we can just kind of shove a whole bunch of data in there. There's not a lot of enforcement for what we can put in there. It can be difficult to work with. It's often slower than working with data warehouses, especially for BI use cases. And we often can suffer from what's called the small file problem. So maybe we have lots and lots of many small files in a data lake. Our engines might actually spend lots of time opening small files or very large files rather than actually analyzing the contents of those files and returning results back to us when we're trying to work with that data. So that's kind of our two worlds. Is we have data warehouses, which are really good for one thing. We have data lakes, which are really good for one other thing. For these, they have their kind of expertise in these two different areas, but not really one kind of unified place to do all of these things. Question?
Yes. So ours it's actually a data lake platform. And that's the reason maybe like we do have like a lot of issues when trying to run some SQL scripts in the Python scripts on the certain catalog tables.
Mm-hmm.
Ours it's currently on the bronze and recently being moved to the silver, where we written some custom scripts to refine the data tables. So yeah,
Yep.
I think this is
Okay.
like more
So so you're saying though that today, kind of like in Databricks in that bronze layer, you are seeing some performance challenges with some of the querying you're doing?
yes.
Okay. Yeah, so I'm happy to dive into some more detail there. I think when we get into a part of what we'll discuss today is some of the like performance optimizations and some way to ensure that you're extracting the best performance from your Delta tables. So maybe at that time, I'd love to chat a bit about kind of what you are experiencing, some of the problems you're having, and then maybe some suggestions for how you might improve performance for some of those tables.
Okay, sure, Declan, that would be really helpful.
For sure. Cool. So then the idea with, actually, I don't think it's, this is not the, yeah, okay. So what are the challenges that we're facing if we just have kind of isolated warehouse and isolated lake? Typically, it's reliability. So we lack ACID transactions in the data lake. And we have kind of different pipelines for batch, different pipelines for streaming. There's no way to unify that. Performance, like I said, we might have our small file problem. We might have some different object store limitations. There's no kind of one place that supports all of the different use cases we might want. So data science, AI, BI, and then openness. Oftentimes we have to use proprietary tooling as opposed to something that's open source. And that's ideally what the Databricks Lakehouse and Delta is intended to kind of bridge the gap for. Delta was created in 2020, and the idea is that it is this one data format that when in your data lake can enable the kind of performance, the reliability that you expect from a data warehouse, but in the data lake. So you get the economics, you get the flexibility from different data types, the ability to work with different languages that you expect from the data lake. So it's the best of both worlds there. So the Lakehouse now, though, it's that data lake. So you guys have your data lake combined with using Delta as the file format, Unity Catalog as the way to govern all of that data. So one single kind of unified place. We love the word unified here at Databricks. One single place to govern all of that data, and then all the tools you need to execute the various use cases, be it data engineering, BI, and analytics, or AI and ML. Okay. So what is the kind of core problems that Delta helps us really get at more of a technical level here? So the first issue that we wanted to solve for was data reliability. So Delta uses Parquet under the hood. You could think of Delta essentially as Parquet with the transaction log. So to have reliable data, we need to have some concept of transactions, which is kind of how we solve for reliability. So basically, this transaction log is what enables ACID transactions. It's what enables this reliability. And we'll see a bit about how the log is created and how it works and how it solves for serializability and availability. But with this transaction log, so we have this concept of table states. So you can add data to your table, and you basically have added a transaction to the log. So if I add data, if I insert, if I merge, if I do some kind of operation on my table, that then creates a new version of my table, and that gets logged in the transaction log. The transaction log tells me what I did. Did I insert data? Did I delete data? What was it? It says this was the operation, and it created this new version of my table. So with this, we're able to get a consistent view of our data and see how this looks over time. So we can actually query the tables as of particular versions. So let's say I insert data on 4 different occasions. I can actually go back and see what my table looked like before I did any insertion. And I can roll that table back to previous versions as well.
Yeah, that's good.
So with this transaction log, we can also do schema enforcement and controlled schema evolution. And so that latter one's actually really important. So let's say that we have a breaking change in a schema where you change maybe a data type from an integer to a string, and then you throw all the data in a folder, and you kind of let the downstream folks deal with the schema inconsistencies later. Well, with schema enforcement, we can build guardrails that are flexible and guarantee the quality of the schema, but also give you that ability to safely evolve the schema as well. All of this then leads us to the ability to do batch and streaming with the same table. So for example, you could have a stream that feeds into a Delta table, and you can have readers going ahead, reading from that same table at the same time, or vice versa. We can update a table as a batch, as part of a batch pipeline, but we can have streams looking at that data and ingesting every time that there's some update that takes place on that table.
Okay. One question, Declan.
Sure.
So you mentioned about this data snapshots, right? Does it also being stored in the same Delta platform that we have? Like within the catalog, it will be stored in the backend, or it
Yeah, so
stores?
basically, the way this works is so let's say that you have a CSV file. Let's say that you read that in to a data frame, and then you write that out as a Delta table in Databricks, and you register that table in Unity Catalog. So then the table's registered in Unity Catalog, but the actual files for the Delta table is stored in your data lake. So it sounds like you use Azure. So all of the actual files, the data itself, would actually be stored in ADLS. And so each time there's an update to that table, the files are in ADLS, but what's basically happening under the hood is the transaction log And basically just that log that is associated with the table is keeping track of what are the active files and what are the active records. So we don't have to fully duplicate the table each time and then just point to different versions of the table using those duplicated versions. We just have one single set of files, and the transaction log is keeping track of what files are active in that table. Does that make sense?
Mm. Yes, and this can also act as like a disaster recovery, like whenever something happens, you can retrieve it, something like
So
this.
there's kind of two different answers there. The first being because it's an ADLS in your data lake. If I remember correctly, ADLS has some redundancy across availability zones. So it should be stored in multiple places by default if it's an ADLS. So there's some disaster recovery support in that way. If you needed more cross-region disaster recovery support, then I think there would have to be some manual um, or at least there'd have to be some additional implementation of something that would help to duplicate tables across regions. And then for disaster recovery of Unity catalog itself, so of the the tables, the schemas, the catalogs, the kind of the relationships between one another. Uh, Support for disaster recovery is just coming out now, and so if that's something that you're interested in is disaster recovery for Unity catalog. That's something that I'd encourage you to speak to Adriana about.
Okay, yeah, sure, sure.
Does that answer your question?
Yes.
Cool. Okay. Last thing on this slide, real quick, is often in the pre-Delta world, doing inserts, updates, and deletes can be really challenging to do. Because if you were to do an insert, let's say, or an update, basically you'd have to completely rewrite all of the underlying files that support that table, rather than just updating the individual file in which you can find the record that's being impacted. So with Delta, we've made it really easy so that you can effectively, let's just say hypothetically, you have a GDPR use case, and somebody says you need to remove a record from this table, you need to delete my data. It's now really easy to go in, delete a single record, and it can remove those individual records from the table without having to completely drop the table and recreate it as one might normally have to do. So it's much more performant and very easy to do with Delta Lake. Okay, so with Delta, there's some additional kind of performance improvements that are baked in. So indexing, skipping, compaction, and caching. And we'll talk a bit about some of those as we go through the demo as well. But this allows for really high performance queries on very large tables. So for caching, we can utilize caching from a Cloud Object Store, so we don't have to read multiple times. We can do Z ordering and data skipping. So basically, Delta knows and the engine knows only to read the files that are associated with the data that we're requesting, instead of, like I suggested with the small file problem, having to go through lots and lots of files just to open and see what data is inside, even if the data that's in these files is not the most relevant. There's joins and cost-based optimizations, and then as well, very high availability for Delta because we're using Spark and utilizing cloud compute. And so workers that fail will bring themselves back up and automatically repair, and unrepairable jobs will fail and then just automatically retry.
Mm.
Okay, and it sounds like you're a little bit familiar already with the kind of medallion architecture here. So this bronze, silver, gold paradigm. So we did not create this idea, this paradigm, but it's a good fit for Delta. And this idea of incrementally improving the data as it moves across the tables. So bronze, that's kind of going back to the source of truth, that's our raw data. And we don't have to always go back to some source system to get the raw data. By keeping it in bronze, we have easier access to this. And as well, there are source systems that maybe don't often keep full histories. So we're ingesting from Kafka, for example, then Kafka might not keep all of the historical data. So to have this kind of bronze source of truth, that could be very handy. As well, this is stored in S3 or ADLS in the case of Azure, and this is incredibly inexpensive So we can store lots of data, lots of historical data very easily at low cost. From there, we move into that silver layer. So we're filtering, we're cleaning, or augmenting the data in some way before we then create gold tables. That's our business level aggregates, something that's ready to be visualized or reported upon. Any questions on anything we've covered so far? Any of the concepts or the medallion architecture?
No, Declan, like right now, because of some business urgencies, so we do have like created uh, the reports on top of some are on the top of the raw zone, and we are like in right now silver. That too, we are creating those silver layer based on the business request only for particular tables. Is that how like usually the companies also perform the silver layer like based on the reports or the business requirements? They do the data cleaning for certain tables or like they do it for everything.
I see. So right now, basically everything is in bronze, and then only when you get requests to move that into a silver or a gold layer, that's when you'll go ahead and do that.
Yes, and that too, those are like I work in healthcare, like whenever we receive a request on like a patient's data, and if we find any duplicates, like the same patients appeared multiple times, then we are like refining those patients' data, creating yeah some patients unique tables on at the silver level, and then we are providing the reports. So is this how usually like companies do?
I see. Okay, so then you'll get specific requests on a particular patients or maybe some group of patients, and then it's only at that time that you'll do some refining of that data. You'll look for duplicates, like you said, and then deliver that in a cleaner state to the required folks.
Yes.
Okay, gotcha. That makes sense. And I have a couple customers that do something similar where, just because of business requirements, they have a lot of data that they put into the bronze layer, but they just haven't gotten around to transforming it further into silver and gold. And so as a result, they're just reporting directly on that bronze data. And so this maybe is something you're already noticing, but typically what that means is, the bronze tables are often larger than a silver table or a gold table, unless we're doing some additional joins. But well, it'll often be a very large table. If we have a large table and we want to do some querying on that table, that might often mean we need a larger compute resource to do that. And it can often just be more expensive as a result because we're querying on large volumes of data versus smaller volumes of data. As well, if that bronze data, that raw data, is something that you're often updating or appending to or inserting or deleting records from, it's possible that we're creating lots of small files under the hood, and we're running again into that small file problem that I mentioned. And there's some pretty basic techniques we can use to kind of minimize that and really rapidly improve some performance that we're seeing on those tables. So I'll certainly highlight those when we get there.
Okay. Yes. Okay. So right now, as I mentioned, the bronze tables that we have, so daily that data gets updated with a sync engine, like from our uh, uh, from our other standard database, main database, where we have the patient record. So daily, whenever the data gets updated, so there is like a incremental loading being happening to these bronze tables.
I see. And then how large are those tables, the bronze tables typically?
I see like some are in even like millions for one of the table I did saw some records are like going in millions.
Okay. And then are they typically pretty wide tables as well?
Not all tables are like white tables. There are like specific tables where it captures all the fields and they're inserting all those field values into the same table. So that's how the main database is being architectured. And when we are doing the incremental loading, so they don't want it to split the table and they're just doing the incremental into the same table.
Okay. Gotcha. Okay. So in that case, I will, there's a couple more, I think just some basic slides here. It's just showing you organizations that use Delta. Okay, and then we actually get into the lab itself. So what we'll do is I'll show you how to get this all set up so that we can walk through it together, but we
Mm,
can then focus specifically on the areas that we think will be the most important for you. Because I
sure.
think by now you probably know how to create tables, you know some of the basic syntax for appending to tables or executing particular merges, but we can still go through all of that. But I'm happy to just spend more time on the things that would be the most relevant.
Okay, sure. Thanks.
Okay. So with that in mind, it sounds like you have access to Databricks somewhere. Is that right?
Yes.
Okay. So then what you'll do is if you just open a notebook, any notebook, and then you can attach it to any cluster for now. Um, but you'll basically just run the following Python commands. And I'll send this to you. So I don't know if you can still see my screen here, but basically we have all these, a variety of different demos that you can run through. So this one's our Delta Lake specific one. And in every demo, it gives you this code that you need to install that demo. So you'll just run these 2 lines of code in a notebook and the demo will automatically install for you. So I'm
Okay.
going to send this to you. I'm just going to drop this um, in the chat and let me know if you get that link. And then if you grab that link, you can grab the 2 lines of code and then just run that in the notebook.
Okay. Sure.
And then you just let me know when you get to here and we'll keep kind of moving forward. Um, and then as well, we can take a moment to talk about clusters and then I'll just set up the workshop. So let me know once you've started running the code. When you've run the code, I'll kind of talk about the content of the demo that's being imported, and then we can start the demo and we can talk about clusters.
Okay. I haven't yet received the link that you sent on site.
Say that one more time. You've been able to access it, or you cannot.
Oh, I haven't received the link that you mentioned to send.
Oh, I see. Let me put this in. If you see in the Zoom, there should be a chat icon in addition to the Q&A icon. It should be in the chat.
Yes, I'm in the chat, but line see who can see the messages.
And if not, I'll just show this screen so that you can just grab. I can actually.
Okay.
It's just going to be this pip install DB demos,
Yeah.
followed by. I can read this off to you as well. And if my screen's not big enough, let me know. I can change this up a little bit.
Yes, I'm good.
Okay, awesome. So you've run this one, and then everything is downloading.
Yes.
Okay, perfect. So real quick, we've talked about why Delta Lake, so I won't spend too much time here, but basically just to reiterate some of the problems, it can be difficult to append data. Data is arriving uh, often, then that can lead to incorrect reads. So if we're trying to write and read from the same table, modification of existing difficult can be difficult. Excuse me, of existing data can be difficult because we have to often recreate tables. Jobs failing can lead to inconsistent writes. Maybe we've written half the data and it's not able to kind of undo that operation before we restart that job. It's difficult to mix real time with batch operations. It can be expensive to keep historical versions of the data. Handling metadata can be a challenge as well, as metadata grows really large in data lakes. We have our small files problem, like we talked about. Extracting performance can be difficult. And then as well, we can encounter lots of data quality issues. So with Delta, effectively, we're able to solve for a lot of that. So we have ACID transactions for reliability, support for DML, so deletes, updates, and merge, and to do that really efficiently so that we don't have to rewrite data. And then time travel so we can look at what data looked like previously. Clone zero copy so we can make clones without having to fully copy data as well. Generated partitions, we'll talk a bit about the change data flow we will not touch on today, but I'm happy to talk about that later on. And then as well, really great performance with Delta. Okay, so these are the kinds of features that we're going to cover today. As a part of this, so once this is finished downloading, your screen is going to look kind of like this here. You'll have these 6 notebooks, so 0, 1, 2, 3, 4, and 5. Notebook 0 just tells you what is in each notebook. So it tells you, okay, this is what's in notebook 1, what's in notebook 2, etc. We are going to cover notebooks 1, 2, and 5 today. So notebook
Okay.
1 is just the basics of Delta. Some of that you might already be aware of. So you tell me kind of as we're going through if you think you want to just skip something because you think you've already seen it, you don't need to see anymore. And then we'll talk about performance optimization. So that's notebook 2. I think this is where we'll find a lot of value for you. And then we can talk about the Delta Lake internals. So actually, how does this work under the hood, which will give you a good understanding of then how to optimize properly. Sound okay?
Yeah, sure, that's it. Yeah.
So when you download the demo,
Mm,
often it will create a cluster for you. So we'll see here, it should say interactive cluster for the demo. It gives me this cluster. It says you can refresh my cluster here. So do you know if you click into compute on the left here, do you see a cluster that was started for you there?
yes, yes,
Okay.
it's running.
Okay. So we'll just work with that cluster for today.
Okay.
But just while we're there on the cluster screen, are there questions that you had about working with clusters, using the right size cluster, anything to that effect?
Yes. So we do have like some workflows, Declan, that runs every 10 minutes. So right now, our complete organization, we do have like multiple vendor teams working on the same Databricks environment. So, and these jobs are also like working, like running for every 10 minutes and multiple times in a day. So, whenever everyone like trying to run those, I see that it is taking time. So, I believe that we haven't configured the cluster properly, or how do we like properly configure the cluster? So those are the questions that I have. So right now our cluster is like 14.3 LTS Spark 3.5 point. Oh, sorry, it's in the standard DS3 family cluster with
Yep.
14 GB and 4 cores, and workers are like 28 GB and 8 cores.
Okay. 28 GB. And then how many cores was it total?
8.
8. Okay. And is that just the one driver or do you have workers as well?
That's it. I have like a workers, 2 workers,
Two workers.
uh, 2 workers. That's for under DS3 family V2 with the 28 GB and 8 cores.
And 8 cores. Okay. And is that 28 GB and 8 cores per worker or is that total?
Uh, it's total.
Total. Okay. And then on average, for those jobs that you're running, how much
Mm.
data is being ingested from the source system and then appended to the bronze tables?
Um, it's around like I didn't actually check the size of those tables because this is being like completely taken over by external vendor team, like they work on the
I see.
same platform. But I did run like a couple of tables where it has like thousands of like it's in 100K, and yeah, so that,
Okay.
yeah, that volume of data.
So basically, I mean, even if it were like a million records, I'd feel
Mhm.
pretty good about it unless it were super wide data. Like I would think that 28 GBs of memory should be enough. So if you think the performance though is not terrific, then one thing you can do is we can look at the Spark UI and we can look at some of the metrics. So if I go into the Spark UI in this cluster, we can start to get a sense of, and actually, before I go into Spark UI, let me actually just go right into the metrics. This is a little bit easier to understand. But we can actually just understand what the CPU utilization is on that cluster. So in this case, I'm not running anything on this, so my CPU utilization looks pretty good. And we can see just in general for this utilization, I can see how much of it's being consumed and at what time it's being consumed. So I would say for the jobs that you have running or that have run in the past, you'll still be able to access this screen. So you can see exactly how much CPU is being used, and then as well, how much memory is getting used as well. So you can see I have a lot of data cached in my cluster. I've got about 32 GBs available to me. So the fact that I've already got 18 GBs cached, as well as another 10 in use somewhere, that's pretty good. I'm pushing the limit here. So if you're finding that your memory is often super high, or that your CPU utilization in particular is super high, then it might be that another cluster or a larger cluster you might benefit from. Or it might be that in the code, there are a couple things that can be done to help reduce CPU utilization and improve the amount of memory you have available. So for example, if in the jobs you're caching data often, then every opportunity that you no longer need to have that data cached, you can uncache and you can clear the cluster memory so it can proceed without having all that memory occupied. And that would help to improve some of the performance of the cluster itself. Does that make sense?
Yes. Can I send you the screenshot of the cluster utilizations right now that I have? So you
Yeah,
can just,
absolutely. And in fact, let me see if are you able to on your Zoom screen, do you see the option to share?
um, no.
Okay. Yeah, if you can, then go ahead and let me send you my email and then go ahead and send that to me. You can send me a screenshot and I can
Okay.
pull it up on my side and we can talk through it.
Yes, sure.
In chat. Okay, I'm gonna put it in the chat here. And ultimately, you can see my name, my full name, right? Definitely me.
Yes.
Okay, it's just my first name dot last name at
Mhm.
databricks.com.
Okay. Sending you.
I'm just refreshing
Alright.
my mail here to make sure I'm getting this all right.
Yeah, sometimes mine it's slow. Just trying to see if you can
Hmm.
see.
And do you know as well, is the cluster that you're using, is it an all-purpose cluster for the job?
Yes.
Okay. So one thing I might recommend as well then is using a job cluster so that it's dedicated for that specific workload. Because in an all-purpose cluster, if it gets shared across many things, it's
Mm-hmm.
possible that maybe many different processes are caching data to it, are consuming memory from it, and then ultimately that's contributing to poor performance on that cluster. But let's take a look. I just got the email, and now I just need the one of the perils of me being in Vermont is that my Wi-Fi is rather poor. Um, but okay, I'm looking now. This looks pretty healthy. It looks like it's an okay amount of cache data. I can see some spikes in CPU utilization. Let me actually, I can pop this up here. Um, but in general, this looks okay to me. Is this the cluster that you're using to connect to Power BI?
Ah, yes, correct.
Okay, so this is used for Power BI and you're running jobs on it. Is that right?
Yes, I'm running jobs on it, and it is used to connect with Power BI, and there are some workflows. Like,
Yep.
yeah,
Yep.
yeah, and
Okay.
there are like multiple vendor persons. Like, they're also trying to run their notebooks on the same cluster.
I see. I mean, in general, the cluster looks pretty healthy. If we're
Mm,
still seeing some poor performance,
mm.
then the next thing I would go for is the the tables themselves and optimizing the tables themselves. And so we can talk about that next. The other thing to consider is just to make sure that actually the work is being distributed on the cluster. So, for example, like, do you know if a lot of the code is actually using, is it pure Spark, or is it making use of, say, pandas, for example, or just plain Python that maybe is single-threaded?
So most of the code that they use a normal Spark and like Spark just mm, for faster. And then it's mostly on the SQL side and Python. I don't see the libraries. I didn't look into their code much. Yeah, it's like mostly Declan like vendors are working on the platform than us. So
I see.
yeah,
Okay. So in that case, I think it's probably the cluster is probably fine. I think then as
yeah.
well, because one thing I was just checking for there is to make sure that actually the work is really distributing on the cluster rather than just overwhelming the driver without the workers being used at all. And it sounds like it's generally okay. So in that case, let me just show you real quick some of the concepts in the first notebook here, just to make sure. We'll just check to see if there's anything here that would be valuable for you. But then otherwise, I think we'll just go right into the second one and we can talk about performance.
Okay.
So real quick, this is just some getting started stuff. So it's even if if you wanted to run this side by side, what I'd recommend is we'll run this top cell. That'll give us these widgets here. And then we'll run this next helper command. And this is
Mhm.
basically just generating some fake data for us to work with while we execute the demo. But just quickly, so you can see what's in here, there's some basics around, using the notebooks. So this is a SQL notebook, and here in SQL, I'm creating my table just based off of some Parquet data that's located at a file path in S3 or in ADLS. It then shows I can do the same thing with Python, talks about magic commands a little bit so that we can flip between SQL and Python in the same notebook. And then we start to talk about some batch and streaming operations. So we can create streaming views. We can see data as it goes into that view, and then I'll just be reading from a static table. So just some streaming and batch operations here. And then we'll talk about DML, so updates, deletes, merges. So far, anything here that you think would be valuable for me to spend more time on, or no, you feel okay with it? You feel okay with the concepts and you don't really need me to go over them?
Yeah, definitely I would like to go on the streaming batch and yeah.
Sure. Um, so I'll come back to the streaming and then the deletes, updates, and merges you feel pretty comfortable with?
Yes.
Okay. And then we talk a bit about constraints. So this is just as we start to enforce some quality in our data. So maybe at the silver layer, the gold layer, I might say, alter my table. So I'm adding this constraint that says check that this column ID does not have a null value. And if I try to insert into my table a place where ID is null, it fails. So there's just a bit about data quality. There's a bit on time travel. So we can look at this is the transaction log for my Delta table. I can see the operations that have taken place, and then I can roll back to previous versions of that table. Between data quality and time travel, would either of these things be helpful to talk through?
Yeah, I have one question, Declan. Like,
Sure.
how long can we time travel within our like tables? Like for some of like it's like been 7 days. And fail safe, it's something like we have like 60 days. So for Databricks environment, how many days do we have for time travel?
Yeah, I believe the default is 30, but it's fully configurable. So it's up to you if you want to change that retention period to something shorter or something longer.
Okay.
But I believe it's 30. I'll have to double check that, but I think the retention is 30. And there's kind of two different retention periods here. So there's the retention for the logs themselves, and there's the retention for the files that the logs reference. And I believe the default for both is 30. But again, they're fully custom configurable.
Okay.
Otherwise, though, it sounds like you're familiar with time travel here and some of the syntax of going back to previous versions like this.
Yeah.
Okay. And if not, and if there's, I don't mean to suggest that we shouldn't cover these things. If there's anything in particular you want to spend more time on, we absolutely can. But I just want to make sure that we spend the time on the things that are most relevant.
Okay. Yeah.
Okay. So we talked about restoring to a previous version. There's a bit about cloning. So on deep clones and shallow clones, and
Uh,
then generating.
but not on a like a data run. Yeah. But I feel um those are like both are like similar concepts where we'll have like a partitioning
Yep.
techniques and with time travel or fail safes or like um even with the clustering keys like where do you use like yeah to sort and those concepts are being very similar here. Yeah.
Yeah, they should all be relatively similar, I would imagine. And
Yeah.
I think as well, like what part of the big magic is with Databricks is it's not that, hey, here's some revolutionary features. I think what's remarkable is that all of this is being done on the data lake itself. So it's that significantly cheaper form of storage, but you're still getting the features, the performance that you expect from a data warehouse. And then the
Mhm.
support to then go and do the machine learning that you'd like to, the BI that you'd like to, all those kinds of use cases.
Yeah.
Okay, so I'll come back to streaming. It sounds like that's the one big item in this notebook that would be helpful to take a look at. Um, in that case, let's just pop over to notebook two. We'll talk a bit about performance optimization for Delta, which I think you'll benefit from in the short term, and then we can come back to streaming.
Yeah.
Okay, so there are some old and some new methods for performance optimization. We'll talk about some ones first, and then we can talk about the older ones. But um, the the first one that's mentioned here is liquid clustering, and it's basically a replacement for partitioning and Z ordering. So I'll talk about Z ordering, and we can talk about partitioning, but um, in general, I would recommend liquid clustering over either of those. Um, so layout in general is pretty critical for the sake of performance and query speed. And manually tuning with partitioning is often not the most efficient, and it can be difficult to maintain this. So with liquid clustering, we're trying to solve for that basically um, in such that we can kind of specify on any column where how we'd like to cluster the data, and this will provide uh, fast access when we query on that column, even if that column is of high cardinality or would typically create data skew when otherwise partitioning that data. So it's super simple. We'll set a clustering key, and there's no need to worry about traditional considerations like cardinality, partition ordering, or creating artificial columns. It's super efficient. So it can incrementally cluster data as new data arrives. And you don't need to trade off between improving performance with reducing cost or write application. And then it's flexible. So we can change the column on which the data is clustered without actually having to rewrite the entire table. So you mentioned to me you're already using DBR 14.3, so you're good to go to use liquid clustering. The only kind of command that you have to run, so we'll show this for, in this case, this is for a new table, is I say create replace my table, use your clustering, and I just say cluster by, and then I add the columns on which I want to cluster my data. And this is effectively, I'm accomplishing the same outcome as I would with partitioning and Z ordering, but in a
Mm.
much more efficient way. And you can see just from this little chart here, what kind of performance we get when using liquid clustering versus either the classic partitioning or Z ordering.
Yeah. I see that.
So I highly recommend clustering for one. If you then describe your table that has clustering enabled, you can see under this column name and data type section here, we have this clustering information section, and I can see on what columns I've clustered. trigger this to incrementally cluster the data, you'll just run optimize and then your table name. Now, the optimize command is what I want to talk about next, because that I think is going to be really critical for you for performance improvement in the short term. I think I'd recommend this. We can even try this now, is to have you optimize one of the tables and then rerun queries against it to see what kind of performance you get. But
Okay, sure.
like if we just run this here, if I say optimize followed by
Mm,
table, excuse me, my throat's a little bit dry. What it's doing is it's compacting the files that back up that table, or that back that table, I should say, so that I have fewer, more evenly sized files rather than lots of various sized files, which can be more difficult for query engines to sift through. So in this case, I don't know if it's actually going to show us, but let's just take a look in here. We have this. Okay. Yeah. So if I run my optimize command here, I optimize my table, then it'll actually tell me what just happened. So I can see this is in AWS, so I can see the S3 path at which my table exists. In my metrics, I can see what just happened. And it says it added one file, removed 5. And what it means by this is it just compressed 5 files into one. So now I have far fewer files. It looks like in this specific case, it went from 5 to 1. In the past, it's gone from 8 to 1, depending on the amount of data that's being worked with here. But just so you can see exactly how that works.
mm,
So if I look at the delta table itself, I can see that my delta table, like if I go back to here, here's my table. You can see there's no file extension. So this is just a
yeah,
directory. And at this directory for my table, there's a bunch of Parquet files that back up that delta table. And so if I go into that directory, this is what I would see, is I have all these little Parquet files. So in this case, it's going to be 13 Parquet files, and then I have my change data log, and I have my delta log. So we can ignore those for now. So it's 13 different Parquet files. But if I run the optimize command, which is what I'm doing here, that then actually gets compressed to 1, 2, 3, 4, 5, 6 files in this example. So now suddenly I'm more than cutting in half the number of files that I need for my table. They're much more evenly sized, and my query engine can go through this a lot faster. And that's just through running this one command here. So typically we recommend enabling or optimizing all of your tables on some kind of cadence. And so that might be weekly, it might be hourly. It depends on how frequently you update your tables. I think you mentioned that you update your tables a couple times a day. It might be worth
yes.
either in the job, just including a command to optimize that table, or having a separate job that runs maybe once every few days that just optimizes the tables that you're updating.
Okay, yeah, got it.
So that should hopefully dramatically improve the query performance. Does that make sense? Any questions on liquid clustering or on optimizing?
Not exactly. I was familiar with this concept, but yeah, this is great. I haven't seen it from the Databricks and side. I used to do it on the Snowflake. I never worked on this.
I see.
And recently, we were wondering like what optimization techniques I can perform, but this is really helpful. I can like have a note of what can be done and
Yep,
go there.
absolutely. And then as well, I don't know, let's actually take a look. There's a newer feature called predictive optimization. And so this will actually take care of a lot of that for you. And so let me open this up. I'm just trying to remember what the circumstances are that this actually gets enabled.
And that feature is only available within the Unity catalog, you
That's
said?
right. Yeah, for tables that are in Unity Catalog. Do you
Okay.
have tables that are in the Hive Meta Store?
Yes, actually, we only have the high metas too.
I see. Okay.
Yeah, we haven't taken this Unity catalog. Yeah.
Okay. No problem. I'm sure I'm sure you're being told by everybody at Databricks that you talk to that they'd like for you to migrate to Unity Catalog. And so I'll join the chorus and also echo that sentiment that I certainly recommend you migrate to Unity Catalog. But um, predictive optimization, that will be for Unity Catalog specifically. So then that'll just take care of optimizing for you.
Mm-hmm.
But even without Unity Catalog, you can still take advantage of these optimize commands and for liquid clustering. That's no problem.
Okay. Yeah.
Also, down in this notebook, there's some comments on Z ordering. There's some comments on generating dynamic partitions, but in general, I would only recommend using liquid clustering instead of Z ordering and manually executing partitions in that way. Do you know, are your tables partitioned today?
Um, no.
No.
So only like
That's good.
yeah.
I think a lot of customers that I'll ask that to, they'll say yes, they partition. Maybe they partition on date. Maybe they partition on a high cardinality column. And ultimately in Databricks, if your partitions are like if your table is smaller than a terabyte and your partitions are smaller than 1 GB, that often will not help performance. So only with really, really big data do we see that partitioning really starts to help. So I'm kind of glad that you don't partition today.
Yeah. Yeah, and probably I mentioned right. One of the key table that we have, um, like it's a field table that EHR field table that we have. So it actually has like lots and lots of data. Like I mentioned, like millions of data, and that data gets updated. Maybe we can think of partitioning that table can help, I think.
I would start with liquid clustering for it. And then if you really don't see the performance from liquid clustering, then you can think about some manual partitioning strategies. But in general, we will always see better performance with liquid clustering than we do with partitioning. Um,
Okay.
and even at millions of records, I mean, if that thing is not topping, let's call it even 500 gigabytes, then I still would not necessarily recommend partitioning that.
Okay.
Cool. So optimize, I think, is step one. Z ordering would be my recommendation for step two. And then if we still don't see additional performance improvements after that, then I would reach back out to Adriana and maybe ask her for some additional guidance on what can be done to improve performance.
Okay. Sure.
Do you know, are there kind of certain performance metrics that you're looking to hit?
Um, Not exactly, but I do have the same in mind. Like, how do I implement this clustering case? Like, so on what basis, like, should I have this clustering case to be implemented on a, like a table whenever I was like trying to retrieve the data from the table. So based on my search, do I have to have those clustering keys?
So if you're going to often be querying the same tables and you're going to be using the same kind of predicates in those queries, then I'd recommend clustering that table on that column that often is in the predicate or that often is the predicate. And it would be as like, let's say that in this case, we have our table. The table is called user clustering. Let's say maybe I query my table often by these columns. I want to say where ID equals something, or first name equals something, or last name equals something. Then I
Mhm.
would want to cluster that table on those columns. And it would be for an existing table as simple as a statement like this. I'd say alter table, state my table, and then I would tell it to cluster on the specific columns that I want it to cluster on. That's it.
Okay. Yeah. So ours, it's mostly the appointment tables that we have. In that appointment table, it's like a major hub for every table joins, like all the patient data we'll have in one table. So that's where we have the patient ID. Based on that, we will connect with all the different tables. So I think in our case, it would be like a patient ID on appointments table.
Yep, I think that makes a lot of sense. I think if that's
Mhm.
the one that often across tables you're going to be using, I think that's perfect.
Okay. Yeah. And what about the materialized views? So do we also have this concept in the Databricks? Like,
Yep, absolutely. Um, how would you like to use materialized views?
So we do have like some historic or like a daily varying historic values. So maybe like a materialized views is something like it stores this cache, right? So we don't have to like re-execute the whole thing. So I think like in that way, maybe whenever we are trying to query the same thing, I can use this concept of materialized views to at least reduce computation time at point.
I see.
Yeah.
Yeah, you just have some metrics, some queries, some tables that effectively you just want to be able to incrementally calculate some results for and not
Hmm.
have to completely rerun those queries every time.
Yes.
Yep, makes sense. Okay. I'm just double checking real quick. It may be we may be out of luck with materialized views as well in regard to Unity Catalog. It might be something that requires Unity Catalog. I'm just going to check real quick to make sure if that's the case or not. Um, Indeed, it does require that at least Unity Catalog be enabled in the workspace and that your Pro or serverless SQL warehouse is enabled to use Unity Catalog. So basically, if let me go over to, just do it over here. Can you see my screen still?
Yes.
Yep. So if I click on create a SQL warehouse and I click in advanced options, I basically would need to use either serverless or
Hmm.
pro, and then I would want this Unity catalog switch flipped. And that would enable me to create and to use materialized views in Databricks. Have you used the SQL warehouses before?
No, we are not using the, yeah, we are
Okay.
only using the Azure sequence storage.
Yep. So what I would recommend, especially for Power BI actually, is that you use the SQL warehouse as the backend compute. So you can think of it as the equivalent to a cluster, but specifically for SQL workloads. So this will actually be much more performant for a SQL workload, like reporting such that Power BI might be doing. If you're querying Databricks directly, today that's using the cluster, I'd recommend instead using the SQL warehouse because it'll actually have better performance for those kinds of queries. And this will also be what you'll use then to create materialized views.
Okay.
As well, I know it sounds like you use the Hive Metastore today. Um, and
Yes.
yes, of course, we'll recommend that you migrate. But even though you're using the Hive Metastore today, you can use that in conjunction with Unity Catalog. So you can keep all your data there. But then, like, let's say you wanted to use materialized views as well, you can just create additional tables in Unity Catalog that read from tables in the Hive Metastore. So you don't have to migrate first before you start to get the benefits of Unity Catalog. You can just turn it on and you can slowly start to have additional tables that live in Unity Catalog if you so choose.
Okay. So in order to migrate the data from a normal Hive metastore to Unity catalog, so do I have to like have this workflows or something like, or do we have an existing functionality to do that?
So if you just turn on Unity Catalog, nothing will
Mm-hmm.
change in the workspace. You can still use everything as is. It just is giving you additional functionality. If you move your tables to be governed by Unity Catalog, then there's some work to be done. And that would be, depending on the table, that can mean copying data because
Mm-hmm.
we have to completely relocate where that table is. Or it might just mean repointing to a different location with no copying of data required. So it kind of depends on some of the nuance for your specific workspace. We have a team of folks that they specialize in Unity Catalog migrations and helping customers understand the level of effort to migrate. If it helps, I can reach out to Adriana and have her connect with one of those folks. And basically, what they'll do is they'll educate you a bit more on what Unity Catalog is and what the advantage is. And then they'll give you a notebook that you can run in your workspace that'll tell you basically how intensive that migration would be. So it'll tell you what are all the steps you'd have to take, what's the level of effort, and you can kind of use that to plan what the migration would look like, or just if and when you'd like to do that migration. Do you think that would be helpful?
Yes, that would be really helpful. Yeah, because in my so previously also I had this discussion with our CEO to implement the Unity catalog because the SOX compliance and HIPAA compliance is required for healthcare. So we are also looking for something like to do the data governance, not just from the Power BI end, but also from the data where we store in the middle, like in the data lake as well. So for that, I did mention this Unity catalog previously, but as we are in the at that time, it's completely in the raw bronze zone, so nobody has like yeah.
Yeah, that makes sense. I think Unity Catalog would help a lot with that. We have some additional features coming out that help with identifying PHI, for example, so automated identification of PHI. You can then configure it to notify you if PHI is detected. You can configure it to mask the data that's considered
Mhm.
PHI. So there are a lot of great kind of governance mechanisms for PHI in particular, aside from all the benefits that you otherwise get from Unity Catalog. Um, so I'll definitely I'll have Adriana reach out to you about that so that we can get the ball rolling on that. Something else as well is if you think the level of effort is high, and if there's not enough time basically for you guys to migrate, but you'd still like to do it, then we can also work with partners to have them execute the migration on your behalf.
Okay. Yeah.
So, okay, I'll have Adriana reach out about that in particular. One other thing I
Okay.
want to show you in Unity Catalog, you may already be aware of this, but let me. So basically, I'm clicking on Catalog on the left here. You know, one of your catalogs will be the Hive Metastore. But if I
Mm.
use any other catalog, and let me just go to this is just my little test schema. I can actually publish this entire schema as a data model directly to Power BI. So super easy. If I have defined my data model, maybe I've got my full kind of star schema in here, or even if I just want to publish particular tables, I can move everything really easily to Power BI and then continuously
Yes.
update Databricks to Power BI from there.
Yes. I'm actually using this
Oh,
feature for
good.
some of
Good.
the tables. Yeah.
Nice. Okay. So anyway, I can talk about Unity Catalog all day. It's a great feature. I'm glad you're interested in it. But just going back to Delta, anything else on performance optimization on the Delta side that would be helpful?
Um, so we almost covered like clustered keys,
Yep.
um, part optimize and partitioning and materialized views. So do you think that there are any other external features that I'm not aware?
I mean, there's so many niche features to always go into. We certainly could, but I think for now you're probably in good shape. I'd say at least for performance, I'd focus on liquid clustering and the optimize. If you don't get the performance you're looking for, I'd work with Adriana on that. I'd also be clear with her to say, hey, here's what our expectations are for performance. Here's where we want to get to. And then she can help kind of guide you in the right direction there. Um, Otherwise, I mean, given what you're working on and given what some of the existing challenges are there anything else that you think would be particularly helpful to dive into?
Oh, yes. I was going through this notebook. I did saw this vacuum. So in traditional databases where I worked previously, we used to do this vacuum and analyze for specific data tables, and that's something like a monthly or like within the quarter in yeah in particular based on like data size and this stuff. So how do we like do it in the Databricks environment? Like um, when do we actually like perform a here? Like yeah.
Yep. So vacuuming, I believe by default, it'll vacuum everything that is um, uh, more than 7 days old.
Mhm.
So then it's at that point, though, it's basically up to you how often you'd like to vacuum. So if you want to retain all of the historical data that even is maybe not being used in your current version of the Delta table, then you don't have to vacuum at all. But let's say that you have deleted a few records from your Delta table, and that was in version 2, but now you're on version 200 of your Delta table. you might think, okay, I don't really need the files that are associated with version 2 anymore. I just need the ones that are still relevant to version 200. But maybe I want to keep everything from version 150 to version 200. Then you could just vacuum everything later than that particular, than the date that after which you no longer need that data. Um, so I'd say there's a kind of general best practice for vacuuming. It really depends largely on what your data retention policies are. But by default, if you do vacuum, it'll keep up to 7 days worth of data.
Okay. So does it means that it it vacuums only those external but, um, so here I see that it's been vacuumed on the table. So what it actually does in the back end when we do the vacuum.
Yeah.
So
So let's say that you have a table, a delta
mhm,
table.
mhm.
And that table consists of five. Let me actually see if I can demonstrate it. It should be in here. Yeah. Okay. So let's say I have my table. This table, um, which I think is no, doesn't matter. These files here
Mhm.
represent a single table. So these are Parquet files. This is the 14 Parquet file or 13 Parquet files for my single table. And then I've run my optimize command here. And like we discussed, what that does is it compacts all of this to then be either in a single file or just in fewer files. So this one takes us from 13 down to 6. So you can see I have 6 files after I've run my optimize command. But what's actually happened is I've run optimize and I've run the vacuum command. So when I run optimize, it takes my 14 files and it condenses the data into 6 files that I actually need. But if I
Mhm.
don't vacuum, the other 8 files are still sitting there, or 7 files, excuse me. So I have 13 and I went down to 6. So I have 7 files that are still sitting there that I don't need anymore because they're not being used in the present version of my table. And so that is what I would vacuum. And I just delete those files that no longer are necessary to my current iteration of the table. Does that make
And
sense?
this is mostly like a metadata that it does vacuum.
It is, in this case, it's also removing metadata, but it's the data itself that was in the table, but no longer is being used for the table.
Okay, yeah, got it. Yeah.
So it may have been used in the last version of the table, but not in the current version.
Okay.
So maybe you say, hey, I want the current version and I want the most recent version. Everything else after that, I don't need any of that information. And so
Okay.
if it's not being used in the existing table, vacuuming will just remove that data so that it's no longer being stored.
Okay. Yeah, got it. Okay.
Awesome. Okay. One last thing, because I know we mentioned this earlier. We just do a quick beat on streaming here. So basically, in these cells here, we've created our table. So
Mhm.
this is just like create my table, user delta. That is from this raw Parquet data. So here's my delta table. This was Parquet, now it's delta. And then the next thing I do is I say, I'm going to create a temporary view. It's called user delta readStream. And what it's doing is it's this spark.readstream.option. Because I specified readStream when I'm creating this view,
Mhm.
this user delta readStream temporary view becomes a streaming view. So if I create that view, so let's say I create this view, that should still work for me. I think I can't remember if I've cleared the state of my notebook and it's going to want me to rerun this, but it should be good to go. No, I have to rerun all of my. So I'm going to reset my data and then I need to specify my file locations. But basically, when I now query that view that I defined as a streaming view, it'll query it as a stream. And I'll actually be able to view that query updating in real time. And so I'll show you
Oh,
what that looks like. We kind of reinitialize here. So do you do any streaming today?
No.
Okay. Is it something that you think you might like to do?
Um, ours actually, whatever what we are storing in the Azure, it's not the direct to DB. So, and we don't have like a yeah streaming data coming. We only do the batch and incremental loading.
I see. Okay.
Yeah.
So no real-time data, not necessarily, don't need to do anything real time in the short term,
Mm,
but maybe just good to know for the future.
yes.
Gotcha. Okay. This should almost be done. I think last time I ran this, it took me just over a minute. Just while this is running, by the way, so I'd recommend you go through all of it just to see if there's some stuff in here that maybe you haven't learned before. But if you want, on that website that I think I was trying to take it to earlier, yeah, that has these demos on it. Like we're going through this one Delta Lake demo here, but there are a whole bunch of concepts on here um, that basically there are these demos that are provided that you can import right into your workspace. So let's say, for
Um,
example, that I know you mentioned you're doing some incremental ingestion. Maybe as
mm,
you set up your pipelines from bronze to silver, silver to gold, you want to implement some more change data capture. There's a full demo in here to illustrate how to do change data capture with Delta. And again, it's as simple as running these commands. You're just specifying a slightly different demo. It'll install those notebooks and you can run through it all yourself. So just a quick call out there while we're waiting here. But okay, we're good to go. Data's reset. Let me create my table again. And then we should now be able to run my streaming query. All right, this is done. Okay. So now I've defined my user delta read stream. And if I query that temp view,
mm,
I'll give this a second, but we'll see that the stream will activate and then it'll start to read from that view. So there we go. I can see my stream's initial. Oh, there it goes again. This is my Vermont Wi-Fi hampering my ability to render the results from my query. Okay, here we go. So we can at least see from this green squiggly line
mm,
that my stream is active. It's waiting for some data to arrive. It looks like it's processed a couple rows, and then I can see the processing go down. So it's processed the data, and there's no longer anything else for it to process. But in this next line, what I'll do is I'll insert some row, just this one row, into my
mm,
user delta table. So that's the original table, not the view. But if I insert this value into the table, well, my view, my streaming view up above is reading from user delta as a stream. So I just added that record here. And now we can see in my stream itself, I can actually start to see where it identified that new record. It ingested that new record. And that's actually just been added to my view here without me having to do anything special. I have my stream running. My view is automatically reading from that table that I've updated as a batch.
this is so cool. Yeah.
Yeah, it's pretty neat.
You don't
So we
have to
can
like yeah run some streaming data pipelines. It automatically does this job by itself.
exactly. And it's so simple just to go from, a couple lines of code that I have my batch table, but that
Mm,
these batch updates can be consumed then as a stream. And so that you can really quickly process that downstream and then visualize it in Power BI, let's say.
yeah.
But anyway,
This is so
that's
cool.
our
It's yeah.
yeah, and that's quick beat on streaming. Um, Hopefully this has been helpful. I know it's been a bit all over, and it's been a very non-traditional workshop. I'm sure you were probably expecting not to have me interacting with you directly, but yeah, thanks for coming off mute and for chatting and for working with me and going through some stuff. Hopefully this has
Yeah.
been helpful for you. You have a couple things you can take away and try. Um, like I said, I'll talk to Adriana and
Mm,
I'll have her reach out to you to start talking about how we can help you figure out what the level of effort would be to do a Unity catalog migration.
yeah, sure. And I would like to say one thing like I feel that Databricks support was doing awesome in interacting with our clients. I noticed it with Adriana and also with you, and this is like a very useful session so far. Yeah, I learned a lot.
That's
Thank
great.
you. Yeah,
It's my pleasure. Thanks so much for the feedback.
yeah,
I'm glad you've had a good experience.
yeah.
If you have other questions, if you need anything, don't hesitate to let us know. We're uh, we're thrilled to be working with you, and we really appreciate it. We're looking forward to continue to do so.
Mm. Thank you, Declan. Yeah, me too.
Awesome.
Yeah,
Thanks so much. Have a lovely
yeah,
rest of the day.
yeah, you too.